This is lesson 10.3, volume of pyramids and cones. To start this lesson off, I want you to watch this video on YouTube. It will be linked on my Canvas page, and I'm going to try to insert it here, but anyway, I want you to watch that so you can see what the visual is of what we're talking about, and then come on back.
In this video, we'll demonstrate the ratio of a volume of a cone and a volume of a cylinder. We have a cone and a cylinder with the same diameter and height. The cylinder is filled exactly with 3 full cones of water. The volume of the cone is 1/3 of the volume of the cylinder.
Okay, as you saw in the video, if you have a cone with radius r and a cylinder with radius r, and they both have the same height, then this cone actually fits in like that. And so you see what happens is the volume, the space that the cone takes up, is going to take exactly 1/3 of the entire cylinder. And so when we talk about volume, we're talking about how much space it takes up. And so in order to find a cone, the volume is equal to 1/3 the area of the base, which is a circle, times the height. And so to find the area of the circle, you of course do pi r squared, and then multiply times the height, and then times 1/3, because that's what you do for a cone. If you look at a pyramid, which this is a pyramid, pyramids can be different depending on their base, so we would call this one a square pyramid because its base is a square. You can have triangular pyramids or other types of pyramids, but it's the same idea. If you were to have a prism, this is going to fit into 1/3 of that prism, and so the volume of that is also going to be exactly the same formula. So if you just think about it as being volume is equal to 1/3 for a a pyramid or a cone, the area of the base times the height, and then whatever the base is, that's going to change your formula depending on if you're talking about a square pyramid or a circular cone or something else. Okay, so let's do an example. The first one, if we are looking at one of the Egyptian pyramids, so we've got this pyramid, and so the base of this is a square, and it says how many 1 by 1 foot blocks. So if you think about a 1 foot by 1 foot block, that's going to be volume. So how many of those did it take to build this pyramid? So we are given some information. The pyramid is 481 feet tall, so my height is 481, and the square base has a length of 756. So the sides are 756. So to find the volume of this, which is what we're doing if we're talking about how many cubes could go in there, we're going to look at our base, which is 756 times 756. So the area of my base is going to be 756 squared. And then I'm going to multiply that times the height. And then because it's a pyramid and not a prism, we're going to multiply by 1/3. So you're going to get your calculator, do that calculation, and you find that it took 91 million, almost 92 million actually, cubic feet. So those cubes that are a foot by a foot by a foot of stone, and you can imagine how heavy that is, and that's how many it took to build that pyramid. So that would be feet cubed. Okay, the next one, let's find the volume of this pyramid. This time we're not given the side of the square. Instead, what we're given is we're given the diagonal. So we need to stop and think about what that's looking like. So if we have the square, we know that this is 90 degrees. So what I really am looking at is this is 90 degrees and the hypotenuse is 6. It's a square, so those are the same. So think about what type of triangle this is, what you know about those triangles, and how do you find the side? Okay, hopefully you remember that this is a 45, 45, 90 triangle. And the legs, If you take the leg times square root 2, that's going to be equal to your hypotenuse. So to solve for x, it's going to be 6 divided by the square root of 2. And so you can simplify that to 6 square root 2 over 2, which is 3 square root 2, and that's the side. And so the area of the base is going to be 3 square root 2 squared. It does look like I left the height off of this, and that's kind of an important piece of this. So the height for this is going to actually be the same as what the sides were. So that's going to also be 3 square root 2. So my height is going to be 3 square root 2 as well, and then I'm going to multiply by 1/3. And so you can put that in your calculator. Now, a couple of things you can do to simplify is you can cancel those out. You know that square root 2 times square root of 2 is just 2, so you've got 3 squared times 2, and then times square root of 2. So that's going to be 18 square root 2. Of course, getting a decimal will make sense here. So I'm going to have 18 divided by the square root of 2. And that comes out to be about 25.455, so about 25.5 centimeters cubed if we round it to the nearest tenth. Okay, the next one we have these delicious supreme pizza cones. So if you look at that, we've got a base that's a circle, okay, and then we've got the cone, and then how tall is it? So it says that they're packed with deliciousness. The cones are 6 inches tall, and they have a diameter of 3 inches. So that means my radius is going to be 1.5. And I do have 2 of them. So how much space is a pizza cone taking up in my stomach when I eat 2 of them? So I'm going to take my volume of the cone. So I'm going to take my pi r squared times the height times 1/3 because it's a cone. And then I'm going to multiply by 2 because I'm eating 2 of them. And so you can do the math. Now, a couple of things we can do is this 3 will cancel out with that. So I'm going to have 2 times 2, so that's 4, and then 1.5 squared times pi, so that's what I'm looking at if you wanted to simplify it. You can, of course, just put that all in your calculator. So that does come out to be 28.27, so about 28.3, and that is in inches cubed. That's kind of a lot of space. Okay, next one. The volume of a cone is this number. The height is 25, and so find the diameter. So that's what I'm looking for. So first thing is start out with a picture. Okay, I'm told that the height is 25, and I'm told that the volume is equal to 10,471.98. And remember that the volume of a cone is 1/3 and then pi and then r squared. I don't know the r part. And then times the height. So I'm going to replace the height with the 25, of course, and I'm going to solve this for r. Now the other thing I've got to put in right here is instead of volume, I'm going to put the 10,471.98. And then solve that. So you can go about doing this like I would multiply both sides by 3. And then divide by 25 pi. So what I've got is 3 times 10,471.98 divided by 25 pi, and that's equal to r squared. My 25 kind of looks like a 28, so I'm going to fix that. Okay, put it in your calculator, and you should get that 400.0001. So about 400. I guess if you wanted to go all the way out there, is equal to r squared. And so you take the square root of that, and that's going to be right about 20. And so the radius is about 20. Now, that wasn't the question, though. So let's go back and look at what the question is, what is the diameter? So you're going to say the diameter equals 40. And that's going to be in millimeters. Okay, example number 5. We've got another one where you're given the volume of a triangular pyramid. So what that means, it means that the base is a triangle, and then you've got, the pyramid like that. So the volume, which is 1/3 the area of the base times the height, is 110.85 cubic feet. The base is an equilateral triangle. That's important to know because otherwise I'm going to have some trouble finding what I need. So equilateral triangle, so think about what you know about an equilateral triangle. The side lengths are 8 feet. So I'm going to draw just the triangle here. And so I have to find the area of that. So it's 1/2 base times height. So 1/2, my base is 8, but what's the height? So I need to find this height right here. This should be a little bit more symmetrical. Don't worry about it. Okay, if it's equilateral, I know that this is going to be 30 and that's going to be 60. And so it's a 30, 60, 90 triangle, which means if the hypotenuse is 8, and I know this is 4, because I should probably draw a better triangle than that. Okay, we need a perfectly equilateral triangle. Okay, so each angle is 60 degrees. If you draw this altitude right there, it also bisects it, so this is going to be 30 degrees. The side is 8, that means this is 4 and this is 4. So using your 30, 60, 90 information, this is going to be 4 times the square root of 3. So I'm going to multiply by 4 square root of 3, that's the height. So this is going to give me the area of my base. So I'm going to write the volume is equal to 1/3. Now the area of my base, if I simplify that, I'll get to my calculator in a second. It's going to be 16 square root of 3. And then I am told that the height, that's what I need to know. I don't know the height, and my volume is 110.85. So you're going to solve that for h. So again, using your skills at solving equations, multiply both sides by 3, divide by 16 times the square root of 3. And that will equal h. So put that in your calculator. You should get the height is about equal to, it's 11.99986. So we're going to say it's 12. If you plug that back in, and you can check that to make sure it works. So if you say that 1/3 and then the area of the base was your 16 square root 3, and then if you multiply that by 12, you should get 110.85 when you round it. So of course you do have your rounding issues, but it's going to be the same number when it gets rounded. So I put that in my calculator, get 110.851. So that looks good. Okay, the last example, again, we've got another triangular pyramid, and I'm telling you what the volume is. So let's start by drawing an equilateral triangle, make it into a pyramid. And it says that it's an equilateral triangle base, and the side of the equilateral triangle is 6. So we've got on the base, if you can visualize it, we've got this. So this is very similar to the one that we just did. So I'm going to have you pause and then just come back and make sure you've got the right answer for the height. Okay, so remember volume is equal to the area of the base times the height and then times the third. So that's for a pyramid. So the first thing I need to do is find the area of my base. So my base is my equilateral triangle. So when I do the area of my base, it's going to be 1/2 and then the base, and that's going to be 6. Number one mistake is saying that that's 3 because you're thinking like 3 right there. Make sure you get the whole base. And then the height. So this right here is a 30, 60, 90 triangle. This is one of the reasons why you accidentally do 3. Okay, but we're talking about the area of the whole triangle, so the base is 6 times 3 square root 3. So that's going to end up being 3 times 3 square root 3. So you're going to have 9 square root 3. And that's the area of your base. So that's my capital B. So I'm going to say 72.12 is equal to 1/3 times the capital B is going to be the 9 square root 3, and then times the height. So I'm going to solve that. I'm going to multiply both sides by 3. And then I'm going to divide by 9 square root 3. Okay, so write it on your paper first and then put it in your calculator. I do expect to see the work that you're doing and not just answers appearing. So show me what you're doing. And obviously be really careful that you're not typing things in wrong to your calculator. You need to check that, and if you don't get it right, you need to go at it until you do. It does not say how to round, and so I'm just going to be consistent round to the nearest tenth like I've been doing. So 13.9, and that is in yards. And so that's how high it is. So 13.9 yards. Okay, you should now be able to complete the lesson for volume of cones and pyramids.